Hello and welcome everyone. So I'll be explaining um, educational round 1 or 2 div 2 problem D, a very good problem, named program. Okay, so in this problem, okay, so we are given a program that consists of n instructions. Initially, generally we're going to be actually given uh, a, a single variable x which is assigned to 0, and we're going to be given a string as a format of the instructions. The instructions could be plus or minus. Plus or minus. Plus means I'm going to add the value x at that position at that time. I'm going to use that instruction step by step, back to back. So I'm going to either increase, it can be of two types of operations, either plus, which means increasing by 1 x by 1, and decreasing x by 1. Okay, then we're going to be given m queries of the following format. After allowing every operations, we'll be given m queries. Okay, and each of the m queries will be given L and R, a range. Now what we have to find in that range is we have to first, what we exactly have to do is from the string, from the instruction string, we will just delete the portion of L to R. Okay, that substring portion will be deleted. Assume that that substring portion is deleted when query L and R are given, and you will add what are the instructions that are left. You will just add them. I'll show you here. Um, let's say for this example, minus plus minus minus plus minus minus plus. Okay, let's take it minus plus minus minus plus minus minus plus. Okay, so this is our instructions, and as I already told you, that our initial x is 0, and each step I have to do the following operation. So it's obvious that I have to make an array to generalize what is the value of x inside there, right? Like for this one, it will be from 0 to -1, then -1 becomes 0, and then -1. Okay, just allowing the operations, that's it, nothing else. Now -2, -1, and -2, -3. Okay, and -2. Okay, so this is the operation. And then, as I told you, that I'll be given m queries. Each of the query will be given L and R. From L to R, let's say I have L to R given as this. Now what I have to find out is, I will delete this part. Okay, this part of instructions will be deleted, so the left parts are what? Minus plus minus minus plus minus plus, right? Minus plus minus plus. Now what I have to find out, that after deleting this part and adding the prefix and the suffix that are left, and on that new instructions, we have to find out how many distinct possible x I can get. That's exactly what I have to find out. Like for example, if I do that, then -1, and then it will be 0, and then -1, and then another 0. Now if you analyze it here, only distinct values are of two types, right? Only -1 and 0. So that's it. That's exactly what we have to find out. So in order to do that, we will I actually used prefix sum and suffix sum. The suffix part is kind of a dynamic part, and I'll show you how to do that. So first, let's focus on the prefix part here. Now it's obvious that if you look at the constraints, we cannot do that in n square time complexity. It's not possible, so you have to just save some values, and that's exactly what we're going to be doing in prefix sum and suffix sum, right? So what actually was my approach? Okay, my approach was, let's my approach was like, let's focus on the prefix part. First, what I did, okay, I will somehow look what I have to find out. I have to find out how many distinct possible values. And what are the instructions? The instructions is either -1 or +1. So, in a sense, if you think that, okay, if after a set of instructions, if I somehow get what is the maximum number that I got and what is the minimum number that I got till that index, okay, let's say I have traversed from this index. Now what is the maximum number that I've got here? The maximum number that I've got is only 0, right? And the minimum number that I got is -2, okay? So if I could somehow store that, I can easily find out what is the distinct value that I have counted till this index easily. How is that? Just do this, because I just do how many numbers are between the smallest and the largest inclusively. So if I just show you like -2 -0, I mean like, sorry, 0 minus -2, right? Maximum minus minimum plus 1. That's all we do, right? How many numbers are there between them inclusively? So what does it give? It does give that I can count only 3. There are only 3 distinct numbers that I can get. What are those? 0, -1 and -2, like this. Okay, so maximum minus minimum plus 1. So the maximum number minus the minimum number plus 1 is definitely going to give me the optimal result till that index. Okay, and now again, why is that actually happening? Because I have only 2 instructions, right? If I somehow have got to the maximum value, then it is definitely sure that I have traversed the values between them. It is obvious, right? So it does make sense that when I try to find out the maximum value and the minimum value, it is definitely sure that I have traversed the values between them for sure, because I have only instructions what, like -1 and +1. It's definitely sure that I have traversed all the values between them, and I have come to a position where I found out the maximum value. So that's how the prefix part is going to hold. So what we're going to be storing, we're going to be storing till any prefix part, what is the maximum number that I've got yet and what is the minimum number that I've got yet. Okay, I mean, while this x is running and changing, I'm just tracking out what is the maximum number till this index and what is the minimum number till this index. Now what is the suffix part? This part is quite interesting, because now let's say we have found out the prefix, right? Let's take a fresh example here. Minus, plus, minus, minus, plus, minus, minus, plus. Okay, let's take a fresh example. Minus, plus, minus, minus, plus, minus, minus, plus, right? And so let's say we are given L and R as this. Let's take one example here from 2 to 5, okay? From 2 to 5, let's say 1, 2, 3, 4, 5, 6, 7, 8. And we're going to be taking from 2 to 5. Let's say we are given any query, we are given 2 to 5. Find the result for 2 to 5. Now, what we said, what we're actually going to be doing, okay? What is going to be the final answer first? The final answer is going to be, okay, I've given this L and R. What will I do is I will find out the best result till L minus 1, which does make sense because I'm not tracking this little part of L to R. And also I have to find out some best results from R plus 1 to till the last index, okay? So that's exactly what we're going to be doing. So we're going to be finding out the best results till L minus 1, which is going to give me from the prefix, right? and what was the best result, the maximum yet and the minimum yet. Also, we're going to have to find out from this part, this suffix part, okay, from r plus 1 to n, we have to somehow find out what is the maximum and the minimum yet. Now, this part is a bit of tricky. If you think that, okay, that's easy, I can just traverse from the last index and I'll just track down the same thing as before, like tracking the maximum like the previous one, just traversing from the suffix. No, it's not going to be possible, because where is actually the instruction going? The instruction is always going from left to right. So if you find out any optimal value from right to left, there might be any possibility that it is not optimal because your instruction is going from left to right. So you would always have to find out, okay, if I start from well, you will always have to find out if the instruction begins from here, then uh, I will find out what is the maximum and the minimum yet. So that's the tricky part. You have to somehow find out this. Like from left to right, you're going to have to find out. You cannot do the suffix part from right to left. Now, to maintain that operation, okay, what you have to do. First, I thought that, okay, so the general approach is, okay, I have found out till the prefix of L minus 1. And what I would do is, if I start, I just thought like that, okay? I just thought like that. If I just assume that from any index, I am assuming that this value was equal to, the x was equal to 0. I'm generalizing every index that I'm going to be starting where x is equal to 0. Why am I doing this? Because x equal to 0 is a number, 0 is a number. If you manipulate it and find out something that gives some difference, and if you add what is the, okay, let me clarify this. I will find out what is the value till the prefix of L minus 1, and I will also have to make sure and keep track that what is the last value that I got till prefix of L minus 1. Okay, let's say it was P. Now, if I somehow find out the changes of this P value from R plus 1 to N, then from that portion, I will find out that their maximum and their minimum, and then I will have like two maximum and two minimum, and then I can compare what is the very maximum and what is the smallest minimum, and then I can find out how many distinct numbers that I can get. Okay, so let's say I've got P till now. This is my current number that I've got, and now I have to make sure that this P is this P values difference of what is it manipulating by and what is it giving the values, and finding out what are the maximum and the minimum. Now for this part, you have to go and you have to think something like DP something, some dynamic way. So yes, you will traverse from right to left, okay, but you're not gonna be just doing the same thing as you did for the prefix, for like finding the prefix one, like the prefix maximum and minimum just you find. Not like that. It's going to be a different in different means by, I will just assume that for every index I will assume, okay, my x was 0 and I'm starting from this index. Now from starting from this index, what can be my maximum value and my minimum value till the last? Now why x equal to 0 that I'm picking? Because if you pick x equal to 0, and if it some times later, if it gives like -5 or maybe 3, then you can generalize this x values difference to any number of values difference. Okay, to any number of values. So if you just generalize the values for x equal to 0 for any number like p, in this case it will be p, let's say for p, you can also find out what is the difference for this, because I am actually finding the difference of x equal to 0 for each and every index. So if I find out that, and if I finally add those difference to the number p, it actually does mean that I am actually finding out what could be the differences for the number p. Because x is 0, it does not manipulate the answer. Okay, so for x equal to 0, you will find out the suffix. If I start from this index, and if my x was 0 initially, then till the last index, what is the maximum that maximum change that can happen, and what is the minimum change that can happen. Now this part you have to go for a bit of dynamic. Now how is that? So what will you do is, okay, for the last index it's 1, and for the previous index, let's say for this index, okay, for this index, what will what I said, I will initialize that yes, my x was 0, and now I have got -1. So if I have got -1, I will add my x I mean, if x was 0, then x -1, which means -1 gives. Now let's say I've already told you I will start from here. I would assume that I am starting from this middle part. For each and every index, I will assume just like that. Okay, so I will assume that yes, my x was 0, and here comes minus, then x becomes -1, and then what I will do, yes, I am starting from here. Now I will start to find, okay, what is the next maximum and minimum that I've got, and from that I will find out what is the maximum and the minimum that I can get right now if I start from here with x equal to initialize by 0. Okay, so that is how we're going to be doing that. And let's explain you with the example. uh, Minus, plus, minus, minus, plus, minus, minus, plus. Okay, so my let's see, -1, 0, -1, -2, -1, -2, -3, and what, like -2, right? Now let's say we are given this as our prefix, right? Like L to R. What will I do? Yes, I will try to find out what are the maximum and the minimum till yet. What is that? The maximum is 0, and the minimum is what? -1. Now what is the final value till L -1? It's -1, right? Now I have to find out what is the -1 values change from this part to this part. Now how will you figure out what are the changes? I've said that first initialize and try to find out the values for x equal to 0. So let's say for this example, x is always -2, right? If x was 0, this is -2. Now for this one, if x was 0, this is what? -3. And also assume and initialize minimum and maximum as 0. So for this value here, the minimum is 0 and the maximum is 0. Sorry, the minimum is -2 and the maximum is 0. Now for this index, if I start from here, what is the value that I can get? -3 initially. X was equal to 0 and -10. Now I will try to find out what is the maximum that I can get and what is the minimum that I can get from the rightmost one. Why? By how am I going to do that? By doing this maximum of, let's say I will try to find out the maximum like this. Maximum equal to -3 of -3 plus 0, right? I'm trying to find out the maximum, so I will check, okay, if this value includes that and finding the next maximum, or this is already the maximum. So it actually gives us the maximum yet. So and if I try to find out what is the minimum that I can get, how am I going to do that? Exactly just like that. For -3, I will try to track, okay, um, from minimum equal to minimum comma of the minimum equal to -3 comma -3 plus -2. Okay, that's exactly what we have to do. So what does this give? -3 plus -2 equal to -5. So by doing this sort of operations, you will find out for each and every index what is the maximum that I got, what is the minimum that I got, and you can find out from here a max min, and also from here a max min, right? Now for if you find out that, just try to make maximum of all these four values. Okay, temporary maximum minimum, temporary maximum minimum, trying to find out the maximum of all the four values and the minimum of all the four values, and then trying to figure out what is the distinct number, which is obviously maximum minus minimum plus 1, right? Let's take you to the code part. You'll understand more here. So this was just the initializing part, taking the test case, small and big arrays, and for the prefix part, this is for the prefix part, and the rest is actually generalizing what is the value that I've got here till, and what is the maximum that I've got till here, and till some index, and the minimum also, and then just traversing the here I'm traversing the command or instructions and trying to find out. This is just the prefix part where I'm trying to find out the maximum yet and the minimum yet, and trying and then assigning those values into that index till yet, and also what is the primary position of that index after the instruction happening. So this is the prefix part that I've got, and the postfix part is here. The postfix part is, I told you, it's a bit of tricky, but you will understand. Let's say when I told you that whenever I get an instruction, I will assume that my x was 0, and then after doing that instruction, let's say for -1, 0 becomes -1 and 0 becomes +1 for plus. And I'm just trying to find out what is the maximum and what is the minimum from those two values. For which was in that index and also the next, which means till the next, I mean from last to the next, what was the maximum plus the current value. Okay, the current -1, which means the -1 actually, which is actually referring -1. Oh, actually, sorry, I actually made a mistake here. I will assume not -3 here. Sorry, not -3 here. I will assume minus. This value is actually referring till what was the value till. Sorry. So for the suffix part, prefix part was good. For the suffix part, what I have to do is, yes, I've got a -1. I will assume that yes, I've got -1, and till what is the maximum that I can get from the post one, which is -2 plus 0. So this will be the minimum. The minimum part is -1 comma -2 plus okay, it's getting messy around. I'll show you. Minus plus minus minus plus minus minus plus. Okay, let's see, we're given this, and I will try to find out what. Let's say for this one. So let's try to find out for this one first. So here we've got a 1. Okay, 1 and 0. 0 was minimum, 1 is maximum. Okay, and if I start from here, what is gonna be my initial? My initial will gonna be -1, 0 to -1, and what is the maximum that I can get? So how can I find out the maximum? The maximum is gonna be maximum of -1 comma -1 plus 0. Okay, and what is the minimum? The minimum is -1 comma -1. Oh, sorry, -1 plus 1. Here it's going to be -1 plus 1, and it's going to be -1 plus 0. Okay, so this is the minimum. That's how you're going to be doing for each and every index. I'm assuming, what will I assume? I will assume that I'm starting from here, and if I start from here, what is going to be the x value? Is going to be either -1 or either -2, just like here. And finding out the same thing here. Look, big 2j equal to maximum of x comma x plus big 2 of j plus 1. Okay, from the increased, I mean the index right after that. Also similarly doing the small, and when I take the queries and L and R, and I'm just gonna be trying to find out the four of the values. Remember I told you the four values that I will get: big and small, and out of those four values I will find out which is the minimum of them and which is the maximum of them. Then I will definitely know what is the distinct values that I can get. I showed you why this is distinct if I somehow find out the maximum and the minimum yet. So that's it. I hope I made you understand. I think it's a very long video. Sorry for making it very long. I had to explain that. Until next time, goodbye.